Hi, this lesson is about Newton's method. So we use Newton's method to find real roots of an equation. So what are roots? Roots are also called zeros, but we also call them the x-intercepts. So in other words, where the graph of the function intersects the x-axis. We find solutions for that by letting f of x equal 0, but sometimes that's really impractical or difficult to do without some sort of technology. So Newton's method allows us to get a really good approximation of what the root or roots would be by using the derivative in a formula. So what I'm describing here is a combination of the intermediate value theorem and Newton's method, because we're going to consider that we have f of x defined on a closed interval, where f of a and f of b are opposite signs and the graph is continuous. And so opposite signs means that, so if you look here at this picture, means that for you to get from f of a down here, so this is a f of a, to b f of b, if they are opposite signs of each other, then the only way to do that is to intersect at some value that we'll call our root c. So otherwise that it would be impossible for the function to be continuous. So it's also true if f of a was positive and f of b was negative, they would intersect somewhere in between a and b. So in order to get some sort of approximation of where the root would be, we start first by taking the average of the two values of a and b. So we add them and divide by 2. And so x sub 1 would be considered the first approximation of where the root is. And then we apply the formula that is considered to be Newton's method. And so the second approximation would be x sub 2 is equal to x sub 1, whatever that average was, minus f of x sub 1 divided by f prime of x sub 1. And then you would repeat the process. Whatever answer you got for x sub 2, you use that again here to find x sub 3. And so x sub 3 is equal to x sub 2 minus f of x sub 2 divided by f prime of x sub 2. So that would be your approach when you don't have a good guess of where to start. In other cases, you might be able to identify your x sub 1 by looking at the graph of the function and estimating a value that's close to the actual root. And so that would be your first value. And sometimes when you're doing homework, x sub 1 might be given to you. All right, so let's look at an example. We want to find the roots, or the root of x squared minus 3x plus 1 equal to 0. Remember, roots exist when y is 0, between x equal to 0 and x equal to 1 by finding x sub 3 through Newton's method. And then we'll compare that answer to what we get by using the quadratic formula. So this is a quadratic equation, so we have the option of using the quadratic formula. All right, so first let's make sure that a root is going to exist. So we have to check what f of 0 is and what f of 1 is. Well, if you plug in 0 into the original equation, you get a positive result. And if you plug in 1 into the original equation, you get a negative result. So because their signs are opposite of each other, it goes from positive to negative, that means there's somewhere in between 0 and 1, we have a root. So our first guess is the average of those two values of x. So it's 0 plus 1 divided by 2, that's a half, or 0.5. So since we now have to evaluate 0.5 or 1/2 in our formula for Newton's method, we need to first find what f prime is. And so f of x is here in our original problem. So f prime is 2x minus 3. So we have to substitute 0.5 into f of x and f prime of x. And so this is what we have to compute. And when you do that calculation, you end up with 0.375. So that's your second guess in terms of what the root would be. And then we'll go on to x sub 3, which is what we were asked to do in the instructions. So x sub 3 means that we repeat the process of using the Newton method formula, but this time our input value into the formula is 0.375. It's the value we computed for x sub 2. And when you do that work, you get 0.381944. All right, so one way to check if that's a good answer, if you were to plug in f of 0.381944, if that's equal to 0 or really close to 0, then you know that's a good check, right? So that would be a good way to check if that's a good root. But we're going to compare it to what we get with the quadratic formula because they should be pretty close. So we're going to substitute here into the quadratic formula. Remember, that's negative b, so that'll be negative 3 plus or minus, and then inside of the radical, it's b squared minus 4ac. So that's negative 3 squared minus 4 times 1 all over 2a, so that's 2 times 1. So when you simplify that, you get 3 plus or minus root 5. So 3 plus root 5 over 2 is outside of the interval from 0 to 1, so we can ignore that one. But 3 minus root 5 over 2. So if you were to compute what that value is, that's about 0.381966. Remember, 3 minus root 5 is an exact answer. This is not an approximation. Once you round off by using the calculator to approximate what that combination of numbers is, this is also an approximate answer, but it should be closer to what the answer is than what we got with Newton's method. Nevertheless, the two answers, the one we got here and the one we got right here, are very close. They're actually exactly the same for the first 4 decimal places. So Newton's method gives you a good approximation to the root. All right, so let's do another example. We want to approximate the real root to 4 decimal places between x equal to 2 and x equal to 3 for x to the 4th minus x cubed minus 3x squared minus x minus 4. So again, we're going to check to make sure that a root actually will exist. This is a polynomial function, so we know it's continuous. There won't be any discontinuities anywhere on the domain, and so certainly between 2 and 3, it's continuous. So when you plug in 2 into that equation, you get a negative result. When you plug in 3, you get a positive result because the signs are opposite. That means that somewhere between 2 and 3, the value will equal 0. So there is some x-intercept or root or 0 somewhere between 2 and 3. So this is our first guess. We add the 2 and the 3 and divide by 2, basically taking an average. And so x sub 1 is 2.5. 2.5 is now the input value into Newton's method. So x sub 2 is equal to 2.5 minus f of 2.5 divided by f prime of 2.5. So we need to know what f prime is so we know what we're plugging into. So f prime is 4x cubed minus 3x squared minus 6x minus 1. All right, so when you compute x sub 2, you get 2.5653. And then 2.5653 is the input value to the third iteration of Newton's method. And usually by the time you get to x sub 3, you're pretty close to what the answer is. So x sub 3 is equal to 2.5653 minus f of 2.5653 divided by f prime of 2.5653. So here, your final answer for x sub 3 is 2.5616. That's actually a really good approximation. And if you were to look at it from a graphical perspective, according to this app that I used, it says that the root exists at 2.562. So Newton's method gave us even better precision than what the graphing calculator app did. So if you have a graphing calculator, you can check it for yourself. If you don't, this is the website that I use. It's also an app that you can download on a phone. So you're ready to try the homework for this section. Good luck.